wants us to graph an equation. So the equation that they want us to graph is y is equal to 3 divided by the quantity 2x minus 5. And so they want us to graph this in our calculator. So what I'm going to do is I'm going to graph this in the calculator. And so what we do a lot of times, and since this section is on modeling, what we do a lot of times is we start with a parent function and we move things around to make the parent function fit the data. So we have to understand how the functions themselves react. And there are certain limitations of the functions. And there are certain limitations of your calculator. And so what we're going to talk about today are the limitations of your calculator. What it looks like on your calculator screen is not necessarily what the graph is supposed to look like, because the calculator can only do certain things. So when we look at this information, as you see here, and I'm going to zoom in a little bit. In fact, the textbooks recommends that we set our x parameters from -3, and this is how they write it too in the textbook. They say -3 to 6 by -3 to 3. So this is your x min, this is your x max for your window setting, this is your y min. So whenever you see this notation in your textbook, what they're saying is graph this equation and set these parameters in your calculator. So we're going to do that. We're going to say 6 -3, whoops, -3. Oh, dang it, I'm almost done. Hit the wrong button. -3. Oh, because it's not negative. Dang it. I keep hitting minus. Do you guys see that? -3. There we go. That's different. And then to 3. So now when I graph it, it'll look just like it does in the textbook. Now the way your calculator works, the way that it plots all these little points, is that it literally plugs in numbers, random numbers, okay? And then it plots all the points, and it plots so many points together that it looks like a curve. Here's the problem. Let me rewrite this equation this way so you could get a clearer understanding of it. It's really 3 over 2x minus 5, right? I wrote it this way so you would know how to enter it in your calculator, but that's really it. So now when we figure out the domain, there are 2 restrictions. You can't take the square root of a negative number and have a real number solution, right? And you can't have 0 on the bottom of a fraction. So when you look at this, if I pick any x out of the real numbers, there's one that will make this equal 0. And that cannot be. So let's solve that algebraically. So what I'm going to do is, we can't have this equal 0, right? This can never equal 0. Ever, 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 ever cannot equal 0. Never, ever. Ever, ever. Ever, ever, ever. So what I'm going to do is I'm going to solve this just like I would an equation, but what I'm really saying is 2x minus 5 cannot equal 0. So I'm going to add 5 to both sides, and I'm going to get 2x is equal to 5, divide both sides by 2, and I get x cannot equal 5 over 2. So I can plug in any number I want, but it cannot equal 5 over 2. Does that make sense? Because when I plug in 5 over 2, what will my bottom equal? 0, and it cannot. But when you look at the graph, watch this. As our x value gets closer, what is this as a decimal? 2.5. So now look, as I get closer and closer to 2.5, as x gets closer to 2.5, watch what happens. My graph starts to go down, it's off the screen. Now watch what happens when we get past 2.5. It's on the other side. So what did it do? What does this line represent? Does anyone in here know? If I were to plug in 2.499999 and hit enter, I get a number. It's a very small number, but I get a number. Okay? It rounds it to 2.5, and we know that we can't plug in 2.5, and I get 0.7015. Okay? So what does that mean? Well, what we're trying to show you guys is that if I were to graph this by hand, the behavior of this by hand, and I'm going to slide the calculator over, when x equals 5/2, we know that this graph can never, ever, ever, ever equal 5/2, right? It can't equal it. So we put a dotted line there to say nothing on this function can ever, ever equal 5.2. So this is our y-axis, this is our x-axis. And so what we're really doing here is we're really graphing this function in a way that as it gets closer and closer and closer to 5.2, it will never, ever, 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 ever equal 5.2. But it'll get close. Now if we come on the other side of 5.2, it'll never, ever, 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 ever equal 5.2, but it'll get close. And that's our function. So what are we trying to say? What we're trying to say is that if you plug this in the calculator, it'll look like this, but you need to know in your head, this is what it's really saying. Because your calculator doesn't have a fancy way to put this dotted line to let you know that it cannot equal 5/2. So the reason we're telling you this is you might do an ACT problem, and then it says solve for the solution, and then it might offer 2.5 as a possible point on the line. You'll pull up the graph, you'll see it, you'll plug in the number, you'll get another number, and you'll say, oh yeah, that's a possible solution, but what do you know? You know that it can't be. So what did I just show you? Okay? Your calculator may deceive you. When I graph this on the calculator, it looks like there is a point that exists. In other words, if I come in here and I say 2.5, I might get an error. Or I might not get a value at all. But if I look at the line and I know that that's 2.5, I'll think there's something there. This only occurs with vertical asymptotes. But you guys still need to know that. Does that make sense?